Okay, for progressive wave, you have a general equation of y equals to a sine omega t plus minus kx. Okay, we also learn how to draw when you have a specific position for time and specific displacement of x. And then 10.2, you learn about standing wave. Okay, here you have a general equation of y equals to a cos kx sine omega t. Okay, and then you learn what is the difference between a cos kx and sine omega t. Maksudnya itu represent apa kan? And then 10.3, you learn about sound intensity, where I equals to power per unit area. Okay, you learn about the unit and how to calculate. So, and today we're gonna focus on standing wave. Okay, but we're gonna focus on the application. Okay, and then lastly you have Doppler effect. Okay, out of all of these subtopic, I think 10.4 could be can be considered as one of the largest subtopic lah. Yeah, when you compare with others. Okay, so in 10.4 you will learn about three main application. Application ada tiga je, so you have three example tu. So that's a good news. Okay, and the formula is given. So normally student bila dia dapat soalan 10.4 ni, the problem is they don't know which equation that they want to use. Okay, mana satu sebab equation ni lebih kurang sama lah. But now the equation is given, so it helps. Okay, and as long as you understand, should be okay. Okay, sepatutnya tak ada masalah. Even kamu tak berapa faham pun, you can still use the formula. Okay, yang stretch string ni, kamu boleh bayangkan dia sebagai like a guitar. Okay, where you have, let's say, this one is a nail being put on a plank ataupun wooden surface. This one is another nail. Okay, let's say you put a string. Okay, make sure the string is stretched lah, tegang, like that. Okay, if you leave it like that, then the length of the string will be L. Okay, and then if you start to pluck, kita kata kamu petik dekat tengah-tengah tu, so it will work like a string kan, it will work like a guitar lah, dia akan start producing a wave. Okay, so benda tu akan start naik vibrating and dia start naik turun. So katakan yang asal dia macam ni, then dia akan naik macam tu, boleh tak? Kalau kamu naikkan lagi, kamu tambah lagi bilangan wave dia akan jadi something like that. Dia bergetar. Kalau dia bergetar lagi banyak, so you expect you have something like this lah. So the bigger the wave, then you have a smaller frequency yang makin rapat-rapat, but then you have a wave profile yang banyak macam tu. Can you imagine that? Boleh bayangkan tak?
Boleh.
Okay, good. Okay, now about the length. So even though once you start to stretch, once kamu dah petik kan, obviously it will start to stretch and then they will vibrate kan. So the length might changes, tapi kita don't bother with that lah. We just want to focus on the initial length tu. Length between the two and two. So later on you will see quantity L tu. So L2 represent starting position dia tu, panjang jarak dia tu. Okay, so itu je. And then we are actually talking about a sound wave. Kita bercakap pasal sound wave. Okay, sound wave ni, kalau dalam pipe pula, dia kamu boleh bayangkan kamu ada, okay, let's say if you have, kalau close end pipe tu maybe you can imagine, let's say if you have measuring cylinder. Okay, if you fill up the measuring cylinder up to a certain point, let's say up to here, this is the water lah. So basically you have one end that is open, okay, another end that is closed, okay. And let's say if you try to blow air from tube kat ujung ni, kali ni dikatakan, okay, doesn't make sense. Padam balik. Mulut, saya nak bikin mulut kan. Okay, let's say if you blow some air, kamu perasan tak kadang-kadang dia ada bunyi?
Ada bunyi, ada bunyi.
So that sound actually because of the sound wave being produced. Okay, but here the sound wave is being produced dekat empty space ni. Okay. Macam tu. Kalau wave dia tak banyak, dia satu je lah. Kalau wave dia banyak and then dia start to multiply lah, macam tadi tu, sama juga. Macam tu. Jadi saya akan lukis betul-betul lah. Like that, and then you have, kalau lagi banyak, then there. Something like that. So you have a high frequency, so everything becomes much more closer, but still you have the same length. Betul tak? The length is from this empty space. Okay. And then that's the idea lah. Kalau you change the L, obviously you will have a different frequency as well. Tapi biasanya L tu constant. We just changes the punya berapa banyak bilangan wave yang terhasil. Okay. And then biasanya kita tak akan lukis macam tu. Instead we will draw something like this. The diagram normally will look something like this. Okay. Biasanya sama ada menegak atau mendatar. But then close end tu maksudnya sebelah tertutup, sebelah terbuka. Jadi kalau dua-dua tertutup, then dia tak ada apalah, tak jadi apa. And then yang the last one ni, you have open end pipe. Okay, open end pipe ni maksudnya dua-dua end dia terbuka lah. It will look something like this. Okay, again, the wave will be produced inside the tube. Okay, so you can imagine that as I increase the numbers of wave, then I will have something like this. Nampak tak? Can you imagine that? Okay. So the higher the numbers of wave, then you will expect the frequency to be higher, dia rapat-rapat, and then the lambda becomes smaller and so on. But again, the length represent the length of the tube. Okay, so far are you guys okay with it? Okay ke tak? You understand that? Okay. So these two, if you notice, dia punya sound wave tu produce dekat air. Okay. So V here, V sound at air. Sebab apa? Sebab wave tu terbentuk dekat air. Okay. Velocity of sound is a constant value. It depends on the question lah. Sometimes dia kata, it depends on the weather actually. Berapa temperature dia. Sometimes they give you 303.15. Okay. Sometimes they give you 333. Okay. So you just have to use whatever the value that is given lah. And the same thing apply for open end pipe. So dua-dua ni adalah dekat air. Okay. But now there's a difference between the stretch string dengan pipe tu. Stretch string pula, the sound wave to actually being produced by the string to itself. Okay, so it really depends on the type of string. Kamu boleh cakap macam depends on types of string lah. So the velocity of sound over here that is being produced is actually V equals to, saya dah tulis kat sini, T over mu. Okay, kita pakai V dekat sini, V equals to square root of T over mu. Yang V lain ni is a constant value, V ini yang berbeza. So remember that. That's one thing that you need to differentiate lah between these three. And the mu is equals to mass per unit length. Mass per unit length apa? Mass of the string divided by length of the string. Okay, so basically you have the mu lah. So the unit for mu will be kg per meter kalau SI unit, and then mass is mass lah. Okay, any question tak so far? Can you follow?
Yes, sir.
Okay, that's pretty much the simple things lah. Benda ni kat sini saya ni. Kalau kamu perasan, tadi saya ada cakap increase number of wave, increase number of wave. Kan? Perasan tak?
Yes, yes.
Akmal ada Akmal? Hasif?
Ada, sir.
Ada. Senyap kan? Okay. Kalau menaikkan bilangan wave, sebenarnya dia adalah naikkan dia punya harmonics. Dan dia panggil dalam in terms of tu, dia panggil harmonics. So you basically have, tadi kat mana dia ada dua cara panggil dia. I'm finding a space to write. Okay, so you have a term that we call fundamental. Okay, if I increase numbers of wave, then dia jadi first overtone. Okay, and if I increase furthermore, it becomes the second overtone. Okay, tapi increase by how much? So dia kita akan tengok lah. So dia increase by the minimum, the least that it can goes up. Numbers yang sebelum ni naikkan satu number of wave. Tapi dia depends dengan alat dia lah. So different alat, different numbers of wave. Jadi kita tengok lah. Tapi the idea is that as you increase from fundamental to first overtone, basically you try to increase numbers of wave. Dia bertambah. Fundamental tu paling basic, paling sikit, paling minimal dia boleh produce, the least. Okay. And then first overtone, second overtone. Itu at the same time dia ada nama panggilan lain. Okay. Fundamental ni also known as first harmonic. Okay. Yang first overtone tu sebenarnya adalah second harmonic. And the second overtone is basically the third harmonic. Okay, so if you just read the names ke apa, dia sometimes dikasih dalam yang hitam tu, sometimes dikasih yang blue tu. So you have to differentiate a little bit. Okay, kenapa nama-nama ni penting? Because after this, kalau dalam exam biasa solution, you have to substitute inside equation. Kamu perlu masukkan nilai dalam equation. Nilai apa? Nilai n. Okay. So fundamental, first overtone and second overtone, nilai n itu berbeza. Contohnya dekat sini, n sama dengan 1, n sama dengan 2, and n sama dengan 3. Okay. This one is for string dengan, saya pakai pen lain. Okay, for string and open end. When we are talking about fundamental, n dia equals to 1. For first overtone, n dia equals to 2, and the second overtone, n is equals to 3. Okay, but for close end part is a little bit special. Close end part for fundamental, n still 1, tapi bila first overtone, n equals to 3, and then n equals to 5. And as it increase, the increase dekat odd number je. Kalau kamu perasan lah. So 1, 3, 5, 7, 9, 11 and so on. Okay, it will be odd numbers. For string and open end, the number will be continuous. Tapi dia round number lah, whole number, sorry. Round bulat kan, nombor bulat. Okay, so far, boleh ikut ke tidak? Lah, but I want to do a summary. Tak adalah summary, still panjang. I still have to explain lots of things. But then, ni a little bit short lah compared to the lecture notes. I will try to put inside a table so that you can compare side by side between those three types of standing wave. Okay, so the three application ataupun the three type, hopefully I can fit everything inside here. Type of standing wave. Okay, and then you have stretch string. Dan kamu ada close end. Dia close end pipe lah. Saya tulis yang short form dia. Sebenarnya kadang-kadang dipanggil acronym. Close end pipe, open and pipe, okay. Okay, and then the shape. Okay, we're gonna start to draw the fundamental mode. Okay, kamu ingat tak fundamental tadi dipanggil juga sebagai apa?
First harmonic.
Yes, very good. Ini nama lain basically yang sama dia. Ataupun also known as first harmonic. Okay, and we're gonna try to draw dia punya shape dia. Kalau string maksudnya dia ada dua end. Sebab dia dekat tengah. Okay, the two end here represent yang tali tu dilekatkan ke ujung tu. Maksudnya tali tu dilekatkan dekat sini, ni kat sini. Nampak? Okay, tali tu dilekatkan dekat sini, ni kat sini. Ini cakap apa? Maaf saya kadang-kadang okay. Okay, jangan sampai suara saya tak dengar daripada lagu sudah.
Baik, sir.
Dah senyap.
Dengar.
Okay. Kalau saya matikan tali tu dekat ujung ni kan, let's say you ikat dekat ujung tu, bila kamu petik, you will expect that the string will vibrate like this. Okay, do you think that this one makes sense ke tidak? Ini saya ada the least amount of wave yang dia boleh produce. So this is what we call the fundamental mode for stretch string. Dia tak boleh kurang lagi. This is the minimum. Okay, so boleh tak kalau saya buat macam ni? Oops. Ayo. If I draw it like this, do you think that it makes sense? Or not?
No.
I don't think no.
Kan? Sebab apa? You can see it over here. Yang this one okay, it makes sense because dia mati dekat sini. Okay. But dekat sini, dia macam tak logik lah. Sebab dia sepatutnya mati kat sini. Kalau dia terbuka macam ni, maksudnya tali tu mengembang-gembang. Faham tak? Dia macam gerak naik, gerak kan? So it doesn't make sense. Sepatutnya dekat ujung tu dia mesti mati juga. So at any point ataupun any position, any end yang dia sepatutnya mati, dia kena ada point lah. Macam yang memiliki kita lukis tadi. So again, I'm gonna redraw. It should look something like this. Okay. For close end pipe. So close end pipe, basically you have one part that is closed, another part is open. Okay. Dulu saya selalu confuse, saya cakap close end kenapa tak tutup dua-dua? Kalau tutup dua-dua mana nak datang sound wave tu, faham tak? So dia tutup sebelah je. So here, kamu rasa wave dia terbentuk Macam mana?
zigzag kan?
Kalau paling minimum sekali. Dekat sini dia titik ke terbuka? Adakah dia dia terbuka ke tutup kat belah kiri ni?
Belah kiri tutup.
Tutup lah kan sebab ini mati kan. So it should end over here as well. Yang belah kanan ni?
Buka.
Dia terbuka.
Okay, very good. Very good. Okay, so that means you guys understand lah. Kalau dia tak ada tutup kat tepi tu, maksudnya dia terbuka. So you will expect dia punya wave dia pun terbuka dekat situ. So the minimum numbers of wave that can be produced is something like this lah. Bentuk macam C tu. Okay. In real world, bila dia terbentuk sebenarnya dia terbentuk keluar sedikit tau. And then ada correction and correction lah. So syllabus lama ada open end punya correction. Sekarang kita dah tak ada dalam syllabus, so we don't bother. Tapi it make sense lah kan sebab kat hujung tu dia macam terlebih sedikit macam tu. Okay, and then kalau open pipe, how about open pipe? What do you guys think? Bentuk
Open.
Yes, open, very good. Tapi open takkanlah dia macam ni pula kan. So dia mestilah jadi macam wave tu. So dia macam ni. Okay. You guys understand this?
Yes, sir.
Okay, so this is the basic. The most fundamental. Okay, and then remember, I told you before that the length is basically the L. Okay, the same thing applied for all three cases. L dia sama. Cara nak kira L dia sama lah. Sometimes dia tak kasih ayat, dia kasih dalam bentuk diagram. So you also need to be able to deduce from the diagram. So that one is your L. Okay, how can I relate with lambda? Okay, this is actually a shape of a wave. So you can see that this is actually part of wave. So if I continue to make a wave, so it will look something like this. Okay, and for one complete oscillation, that one is your 1 lambda lah. So if you're referring to this diagram, which is actually kalau 1 lambda, it's like this, right?
Yes.
So kalau macam ni, berapa banyak lambda?
Tu 1 lambda.
Half lambda.
Half lambda, half.
Kan? Betul tak? Very good. See, this one, the length is actually half lambda. Okay. So how about this one? So this is actually the graph looks something like this. Kita saya lukis satu je. Betul tak?
Betul, sir.
So ini berapa lambda? Ini 1 lambda, yang saya buat ni 1 lambda. Kalau ini separuh lambda, sama macam yang atas tadi. Kalau ini berapa?
Suku.
Yes, exactly. Quarter lambda. So lambda over 4. Okay. Yang this one pula, actually dia adalah something like this. Okay. So if this one is half, tapi kita tak ada potong kat situ, kita potong dekat tempat lain. Ini tadi berapa? Quarter kan? Ke sini quarter lagi. So berapa?
3/4.
Sikit lagi. Lain ada yang nak cuba? Asif? Tanya Asif.
Tadi saya jawab, sir.
Tadi kamu jawab? Alamak, sorry nak. Daniel, harapnya tak ada lagu.
What over 2/3?
2/3. Kurang tepat. Boleh cuba lagi. Okay, saya try lukis balik. 1, 2. Macam mana?
Lambda over 2.
It is actually shaped something like this. Kalau ini adalah 1 lambda. Okay. So kalau saya potong 2, dia adalah separuh lambda. If I cut into 4, this one is quarter lambda. Betul tak? So this one sebenarnya jarak dia quarter plus quarter. So
Half.
half, yes.
Ah.
Half lambda. Tapi susah kan nak tengok kan, betul tak?
Dia susah nak acam sikit.
But don't worry, ada cara yang mudah untuk melihat. So I'm gonna go to the next page first. I'm gonna try to draw you the standing wave. So the standing wave, if I draw long enough, it will look something like this. Okay, saya tak nak bikin banyak lah. I just want to draw for one. Okay. And the same thing apply, tak kisahlah ini, tak kisahlah untuk apa ni, standing wave open end ke, standing wave untuk close end ke, doesn't really matter. Just sedikit balik, sedikit properly. Saya ambil titik tengah. So to draw end over here and over here. Let's say this is my berapa? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it should. Okay, ini untuk satu complete oscillation. Tapi ni kalau kamu bayangkan dia sebagai progressive wave. But since this one is a standing wave, dia ada satu lagi yang patah balik, betul? So that patah balik is actually makes it like macam gelembung-gelembung tu, macam karipap ni. Ini adalah yang patah balik tu. Okay, boleh bayangkan so far? Okay.
Okay, boleh bayangkan.
Okay, and then this one actually for one lambda, one complete oscillation lah. Katakanlah saya nak potong kepada 4. If I cut it into 4, saya macam tak balance ni. If I cut it into 4, then I should cut it into half first. Okay, and if I cut it further, so macam ni lah. Cara paling mudah nak ingat, kalau kamu perasan shape yang ni sebenarnya dia akan huruf C. Betul tak?
Okay, C terbalik
C terbalik. Dan ni pun C juga. Okay. And this one pun C juga. And the same thing happen over there, C tu. So setiap satu C tu sebenarnya equal to berapa?
1/4.
1/4, very good. So I'm going to draw it down here. So, setiap satu C ni is equal to lambda over 4. So as long as you remember that setiap satu C tak kisah terbalik ke tak terbalik equals to lambda over 4, then you can easily count numbers of lambda dalam gambar tu. Okay, faham ke tidak?
Okay, faham.
Faham sir.
So kita pergi balik dekat situasi tadi. So just now we draw the 3 example. Okay, we want to try to apply sama ada apa yang kita apply ni boleh pakai ke tak boleh pakai. Okay, let's look at the first one. Atas sekali. Dekat sini ada berapa banyak C? 2 C kan?
2 C,
C1, 2 C. So 2 C darab 1/4, you get 2/4, which is half. So this one is correct. Okay. The second one, ni berapa banyak C?
1.
1. So you expect this one is 1/4. which is correct as well. Okay. And the last one ni ada berapa banyak C?
Ada 2 C.
Ada 2 C. 1 C, 2 C, which is 2/4 lah, half. Okay.
Okay, faham.
So senang tak nak kira numbers of C dia tu? Senang kan? Then straight away you can determine numbers of lambda dia tu.
Okay, faham.
Okay, that one is for fundamental mode. What if I increase the numbers of wave? Okay, let's say now I'm including the overtones. Okay, now let's say you have second harmonic ataupun first overtone atau second overtone ya. Second harmonic and third harmonic. Okay, for close end, shape dia masih sorry, for string, the shape will always be the same lah. Dia still mati dekat situ, doesn't change. The L also doesn't change. Okay, yang berubah hanyalah numbers of wave that is being formed. Okay, kalau saya nak tambah bilangan wave, kamu rasa mana yang make sense? Should I mean, asalnya macam ni kan, macam sebelah kiri tu. Okay, kalau numbers of wave saya bertambah, kalau saya lukis tambah 1 C, C tu paling kecil lah yang kamu boleh tambah kan. Kalau saya tambah 1 C, dia jadi macam ni. Agree ke tak agree?
Tak.
Kenapa tak agree?
Sebab dia tutup satu dua kan tak?
Kan, sepatutnya dekat ujung tu bertutup juga. Okay. So now yang luar terbuka, so it doesn't make sense. So you have to add one more C. So kalau tambah C lagi satu, jangan tambah macam ni pula. Okay, lagi satu C tu dia tertangkuk lah. Alamak, apa ni? Okay. So if you add one more C, it will look something like this. Okay, tak boleh. Okay. You guys agree with this?
Agree.
Yes.
Okay, so basically syarat dia dekat ujung ni kena matilah sebab dia mati. So you cannot add half macam tadi tu, kamu tak boleh add sebab apa, it doesn't make sense. So you have to continue add. So in this case dia dapat bentuk macam ni. Okay, so L dia masih sama. So L still the same, length dia masih length. Okay, but now the numbers that is changing is actually the lambda. Okay, lambda dia sekarang jadi berapa? Ada berapa banyak lambda over there?
Ada 4.
4 C kan?
4 C.
Berapa lambda?
1.
Yes, exactly. Yeah. So if I try to divide into C, so this would be my 1 C, 2 C, 3 C, 4 C. 4 darab 1/4 becomes 1. So in this case, your L is equals to lambda. Okay, let's say if I want to add another level of wave, saya nak naikkan lagi bilangan wave. Kalau saya nak naikkan lagi, mungkin macam soalan, kalau saya letak macam ni, logik ke tak?
Tak.
Kan macam lah. Okay, very good. So ideanya kamu kena tambah lagi satu lah supaya dia bentuk dia macam ni. Okay. Oops, terlebih. Okay, now I just try to draw it properly. Satu, 2, 3. So the same thing apply lah. Kalau kamu nak lukis lagi, kamu tambah lagi, and then lagi tambah lagi. So Idea dia macam tu. And L dia tak berubah, L dia still sama, cuma numbers of lambda tu bertambah-tambah. So here L still the same. Okay, kalau macam ni berapa banyak lambda dekat dalam ni yang kamu boleh nampak?
3 lambda per 2.
3 lambda per 2. Okay, very good. So kita kira sama-sama ya. 1C, 2C, 3C, 4C, 5C, 6C. So 6 multiply 1/4, you get 6/4. Okay, 6/4, if you simplify, it becomes 3/2. So the answer will be 3/2 lambda. Okay, answer apa yang dia bukannya ada soalan pun, dekat soalan pun. So far okay?
Yes, sir.
Yes, sir.
Maybe saya ajar slow sangat. Okay. So
Sir, jadi saya faham sir.
kalau kamu tengok equation yang asal equation of wave, V is equals to F lambda. If you guys still remember lah. Where F, ceritanya sekarang kita biasa nak cari nilai frekuensi. Okay, frekuensi untuk fundamental berapa, frekuensi untuk overturn berapa. So we rearrange this equation and become F equals to V over lambda. Okay, and remember that lambda tak signifikan kalau kita tak gambarkan dalam bentuk L tu. Sebab L tu kita ada ukuran, lambda tu kita tak ada. So basically each one of these we want to substitute with the lambda ni, jadikan di dalam penyebut L. So let's say if I substitute. Okay, my F untuk fundamental now becomes V. Okay, saya terskip satu tempat tu. Okay, L ni, L here is equal to lambda over 2. Right. So kalau L equals to lambda over 2, if I rearrange, then lambda is equals to 2L. Betul tak?
Betul sir.
Betul.
So lambda is equals to 2L. Okay. Therefore, if I substitute inside balik equation 2, F sama dengan V over 2L. Okay. And the next thing is that L sama dengan lambda. So that one is straight away. Lambda sama dengan L. If I substitute, then my F is equals to V over L. And the last one here is that lambda is equals to 2 over 3L. Saya terbalikkan je, bawa ke sana, bawa ke sini. So this one, if I substitute inside F, so I will get F equals to, dekat bawah kan, so 3, 2, betul tak? Confused lah.
Betul sir.
Dan,
Three, two.
betul lah.
Sebab lambda dia
Bukan
Sebab
3 over
dia-
2 ke sir?
3 over 2, sebab dia 2 over 3 kat situ, so 3 over 2 kat sini. Okay, sorry. V, L, okay, now it makes sense. Kan? Okay, so katakanlah saya letak 1 dekat sini, it doesn't change the equation pun, just multiply by 1. Okay, then here if I add 2 over 2, also it doesn't change, it's still equals to 1 lah. Nampak tak? Right. And the last one is 3 over 2. So if I only see this one, so it becomes 1, 2, and 3. Then the remaining equation is the same. V over 2L, V over 2L, and V over 2L. Perasan tak? So the general equation lambda, F is equals to N V over 2L, where N is equals to 1, 2, 3, and so on. Okay. Okay, I'm gonna skip a little bit. Okay, and I'm gonna straight away rumuskan yang last sekali. Saya kasih soalan jawapan bocor lah. Yang last tu, formula dia exactly the same dengan yang first. Hasil dapatan lah. Okay, the only difference is the V. Okay, yang V dekat sini is a constant. Dekat where V is equal to 203.15 ke, 333 ke, ataupun so on lah. It is a constant value. On the other hand, yang V dekat atas sini is a little bit different. V here is equal to, if you go back ke atas ni, square root of T over mu. Okay. And then, saya akan bocorkan lagi satu. So, yang dua ni sebenarnya sama tau formula dia. And dia pun sama. Yang berbezanya dekat tengah sini. Dekat close end pipe. Okay, dia paling pelik sekali. Dia punya formula is Fn equals to Nv over 4L. Pelik kan? Yang dua tu 2, dia 4. Lepas tu yang lagi oddnya, dia pakai odd numbers of n. 1, 3, 5 and so on. Okay. V ni is a constant lagi dah. V dia sama yang bawah tu. Sebab dia dekat air. Tapi formula dia pelik. Okay. Dia punya kepelikan tu sangat pelik sampai senang nak ingat. Bagi saya lah. Tapi ada student dia confused. So dalam exam, they will give you these two formula. Formula ni and formula ni is given. But they didn't give you the numbers of n. And obviously they didn't tell you which and which lah. Ni nak pakai kat mana, ni nak pakai kat mana. So cara paling mudah nak senang ingat, the first and the third, the formula is the same. N is a normal number. Biasalah, number biasa. Yang peliknya kalau nampak 4 the odd two sit in the middle, close end pipe. The n numbers only odd numbers. Kenapa jadi macam tu? Okay, dia ada reason lah sebab derivation dia. Kamu ada kelas lepas ni?
Tak ada saya.
Mepro.
Oh,
Mungkin Mepro mungkin.
Faham ke tak kan? Mana
On.
On.
Okay. Kita bagi sikit lagi. Again, we use the same concept. L doesn't change. Dia punya pipe tu masih sama. Dia tak pakai pipe lain. Basically doesn't change. It's just that we want to increase the numbers of wave. Okay. Asalnya dia ada satu C. Yang belah kiri sekali tu ada satu C. If I want to increase, I can put one more C. Kalau saya letak satu C lagi, dia jadi macam ni. Logik ke tak?
Logik.
Logik ke? Cukup dek.
Dua sih.
Tapi dekat ujung tu dia mati. Sedangkan kat ujung tu terbuka.
Oh, terbuka. Terbuka.
So dia sepatutnya tambah lagi satu.
Tak logik.
Oh,
Okay.
tambah lagi satu. Okay.
Nah. Okay. Baru saya dengar suara Asyik. Padahal tadi Asyik jawab sorry Asyik. This one, it should look something like this. Mak apa ni? Okay. Kalau saya nak tambah lagi, kalau saya just tambah satu, nanti jadi macam ni lah. Tutup pula kan, start logik kan. So saya kena tambah lagi satu.
Ya.
So it will look something like this.
Yang tengah-tengah tu macam pelayar kan sir?
Macam apa?
Pelayar.
boleh tengok dia macam player. Okay, the best thing kalau ni walaupun nampak macam complicated tapi kalau kamu faham sebenarnya you don't have to memorize anything pun. Macam saya tak hafal pun, dulu saya tak hafal. So setiap kali pun saya beri derive dia punya equation. Okay, kalau dulu this equation is not given, so saya takkan suruh kamu hafal lah. Tapi yang ni equation diberi, so saya galakkan kamu at least kamu faham lah. Masa bila nak pakai atas ni, masa bila nak pakai bawah ni. So yang ni jarang kalau dia suruh lukis lah, jarang. Okay. Tapi kadang-kadang dia suruh lukis. Okay, back to this one. Okay, kita go through very fast. Kita tentukan berapa banyak lambda dekat situ. Yang tengah-tengah tu.
Tengah-tengah.
Over here, berapa lambda? Berapa C? Okay, saya tanya berapa C
Ada
dulu.
3 C.
3C maksudnya berapa lambda?
3/4.
Yes. 3/4 lambda. Okay, yang ujung ni?
5/4.
Okay, 5/4 lambda. Okay, very good. Okay, kalau kamu rasa macam tertinggal, don't worry. Nanti kamu go through balik So, biasanya benda ni saya ajar satu hari tau. Kalau dulu-dulu lah, syllabus lama. Tapi sekarang saya kena compact kan. So, saya ajar tiga-tiga ni satu hari. So, rasa tertinggal tu is normal. Refer back nanti recording and then hopefully you can understand lah. Kalau tak sure, boleh tanya. Okay, so kamu punya lambda here is equals to 4L. Kan?
Betul 4L.
Kalau yang ni,
Yang ni 4/3L.
4/3L.
Yang tu 4/5L.
45.
Okay. So, nombor 4 tu kamu dah nampak kan? Dia ada kat semua tempat. So, logik lah. Tapi akhir jawapan tu ada 4. So, again, kalau saya masukkan dalam F equals to V over lambda tu. Saya masukkan balik di atas ni. F is equals to V over 4L. F equals to
3.
V over 4L multiplied by 3. 3 tu buat atas. F equals to, yes, V over 4L. 5 tu ni atas. So you can see that the number that is changing is this one, this one, and this one. Okay. So itu basically just a 1 lah. Tak nampak lah. So that's why I can write down the general equation to be NV over 4L. So this is the general equation lah. Where N here is the odd number. Kenapa dia odd number? Based on this. 1, 3, 5. And if you continue to do it, you will get the same odd number lah. 7, 9, 11 and so on. Understand or not?
Yes.
Yes.
Okay, so my task is that I want you guys to complete the last one, the remaining one. Okay? It's a simple thing. You will expect to have the same with the first one. So you can try to draw it yourself. Nanti kita tengok on